Here we will introduce this quantization in the previous example. So we have again our signal. I made an ACSI introduction. We have here our update rule, the LMS update rule, but also we here quantize and dequantize step size. So we use a mid-thread, step size of 0.05. So what we're doing here, and then we can compare the mean squared prediction error with the mean squared signal power. What we're doing in these steps here. Now we have here the original signal prediction error, and already see the quantization taking place. So this is how
we shall go on to the end. We shall fight in France. We shall fight on the seas and oceans.
This is how the prediction error sounds like with the introduction of quantization. And now in the decoder, we have here still row. We see that it doesn't explode anymore. We have reconstructed. So
we shall go on to the end. We shall fight in France. We shall fight on the seas and oceans. We shall fight.
So this is the reconstructed signal. Because of the quantization, the prediction error now clearly increased. The signal is now fully decoded, even on this quantization at all, with a little noise. Was to be expected. But we can avoid the noise by reducing the quantization step size. Observe that this is structured for the decoder in the encoder also applies to other prediction methods. So we've seen here how we can introduce quantization with this scheme of a decoder in the encoder, and we can now fully get the reconstructed signal. And there's a trade-off. We have some quantization noise in the prediction error, and this is we can try to minimize this noise by reducing the quantization step. And that's it for the LMS with Quantizer using Python. We reach the end of our notebook and the end of this course. So there is still the multi-rate signal processing course. Will deal with many different aspects of multi-rate signal processing. A very good continuation on the studies of this world of signal processing. Thank you very much, and see you another time.